We are building the Fractals and Recursion project from the YByte Python curriculum available at www.ybyte.in. We saw previously how we could do, let's say, one level of recursion to get something like this, a tree of this sort. Let's say a branch of this sort. So I did, for example, move forward, turn right, move forward, turn right, and recursively kept calling the function to end up with something like this. Based on having built the square pattern, we know that in fact all we need is one more level of recursion to draw me the left branches. But there is a problem here. There's a challenge here. Let's say the challenge is that my turtle needs to be realigned and brought back. In fact, this is probably the most tricky part of the entire tree program. It's interesting to think about how this thing works, and I'll try to go in a very, very step-by-step manner as to how this thing actually works. Why is it that we are doing what we are doing? So let's try to analyze this from the base case. Remember, the base case is where level is 1 and we no longer do any more recursion. However, remember the way our code is written, we move the turtle forward by, let's say, the size, whatever the step size is at that level, and we turn it by a right angle. Now, what that means is actually significant. It means that at the end of the base case, my turtle is not aligned with where it came from. In fact, it's turned towards the right. Now, I am drawing this line in a dotted fashion because there is nothing to be drawn here. Remember, this was the base case, no more recursion. So this line will actually never be drawn, but my turtle is already pointing in that direction. Why is this significant? Well, because remember, I can't just pull my turtle back. It will end up at some other place. In fact, what we need to do is a few steps before I make the second recursive call. My second recursive call has to happen from the start of the last level, which means my turtle has to be realigned, which is here. So it realigned to the original direction, come back to the starting point, and then let's say have it turn towards the other side. Now this is actually a little bit tricky because this whole thing is being done somewhat recursively. And hence, gets a bit confusing. But these steps are very clear that, the turtle must be realigned, brought back, and turned again. And in fact, if you think about it, this angle is going to be 2 times of A. And that's a significant point because look, if this was, let's say, from vertical, say 10 degrees, in fact, we have to turn around 20 degrees because, the turtle has to now go in the other direction. Now, let's just try to, break this down a little bit. We know that we are going to make 2 recursive calls. That we know because the square pattern tells us that 2 recursive calls is all we are going to need. But we will now have to write this additional code to, let's say, do all the readjustment and realignment. Let's say we will do this in 2 parts, code 1 and code 2. Code 1 is this piece of code that I'm going to put before my second recursive call. And code 2 is something that I'll put after the second recursive call. Now, we will understand what code 1 and code 2 should be. But for that purpose, let's again get a bit deeper into, let's say, the base case. Now let's take some numbers here because that makes it somewhat easier to understand. Let's say my, I want to call my branch with, let's say, 100. So size is 100 and let's say level 2. Now again, remember, this could be a recursive call. This could be an original call, right? So it doesn't matter. Either way, it's the same. Let's say I have a branch 102. Now, obviously, I'll move my turtle forward, whichever direction it's in. And I'll turn, let's say, right by 10 degrees, assuming the angle is 10. And the way the function is written, I'm going to call branch 81. Remember, 0.8 times 100, that's 80. And level minus 1, so that's 1. Yeah. So I call in this branch 81. Now I get into my branch 81. Remember, this was level 2. So branch 81 means that I draw my base case line. So I move forward 20 steps. I turn right. Remember, as I told you, we are turning right in the direction that would be the next level, but in this case there is no next level because when I call this function branch 64 because again 0.8 times 80, so that's 64 0. In fact, this code has absolutely no effect. The reason is, remember, our branch code, let me just show you here, our branch code is in fact put it inside if level is greater than 0, which means that if level is actually 0, none of this happens. And that's why I argue that look, this has absolutely no effect. However, code 1 will have an effect. I'll again call branch 64 0 because that's how the branch 81 is going to behave. This will have no effect again, but indeed code 2 will run. So notice here, once I call branch 81, my turtle moves forward, code 1 runs, code 2 runs, I come back to this level, and again code 1 runs before the, let's say the second recursive call is made. But we know that between these two, my 3 steps that I've outlined earlier, which means the turtle realigning, coming back, and then aligning to the new direction. All those 3 steps must happen between, let's say, these 2 calls, which means that code 1, code 2, and code 1 again. Right? So this is very important to understand. Code 1, code 2, and code 1 again together should do all of that, right? And the way we do it is actually quite interesting. We will use, let's say, in some sense, you can argue code 2 for aligning and bringing back, and code 1 for realigning. Let's just see this in action. So let's assume angle was 10. We will ask my turtle to move in the direction -20. Now I'll illustrate this later from a diagram. Remember, when I call 81, I go through all this. So I'm aligned too much to the right. I say, well, go and align too much to the left. Looks odd a little bit, but remember, thereafter I do one more turn right, which means at this point, in fact, at t right 10, I'm in fact perfectly aligned, and I bring myself back to wherever I started from. Remember, I had moved 80 steps forward, so I bring myself back 80 steps. At this point, I'm aligned back. I come back to this code. I do my 3rd step, which is realignment. Again, very nice to see this from a diagram. Very useful, very illustrative. Let's say I define a few points. So let's say at the end of point A, remember, that's the end of my base case. I'm in fact aligned too much to the right. This line is not to be drawn, but nonetheless, I'm aligned too much to the right. So I'm telling my turtle, well, turtle, please, turn a little bit too much to the left. So at the end of B, I am here. Now this looks strange. Why do we do that? Well, because remember, this was code 1. Code 2 has my, let's say, turn right 10. So it aligns me again. That's this statement T right 10. And then this statement C brings it back. So at this point, let's say at this point, I am brought back to the right position. Now all I need to do is, look, I need to turn again by twice this angle, as I said. So if it was 10 this way, I turn, let's say, 20 to the right. Yeah, it's -20 to the right, sorry. And which means that I'm ready again. My next recursion, where it happens, it's going to basically draw a line. And if you think through it, as I recursively call it, it will always keep bringing back my turtle to the original point. And this is actually very powerful. A lot of explanations just talk about what happens, let's say, at this step. Why are we doing -20, or let's say -2 times angle? But in fact, the story is a little bit more involved. As I said, it's this followed by this, followed by this. So if you analyze through the base case, it makes a lot of sense. All these 3 steps are going on. But the point is, at the end of every, let's say, recursion, my turtle will draw those 2, let's say, draw the line and come back to the base. So I'm going to just implement this in the code, in the next video, and pretty much we'll be done with the tree, because all it takes is, like I said, 1 extra recursion, magical as it may be. We'll come back in the next video and implement this code, but think through this. Very interesting, and I've tried to break it down into steps so that we really understand this, and we can really then, once we have a deep understanding of this, we can then tweak this also to do, let's say, more things. I hope this has been interesting to you. Again, look at our website, www.ybyte.in, because this is how we learn Python programming, by building activities, analyzing them, and thinking about every step that's going on in there. Take care. Thank you so much. Bye-bye.